3 tangent squared of x minus 1. And so we're solving. So we're trying to get the trig function by itself. So how would I do that? Add 1. If I add 1, that'll leave me with 3 tangent squared of x equals 1. Next, divide by 3. You don't see orange and red a lot together. That's ugly. Tangent squared of x equals 1/3. I hope that's nobody's favorite colors.
It's mine.
Putting those together like that?
Well, it's like a sunset. And you got to throw a little yellow in there.
Yeah. Okay. And then from here, tangent is being squared, so I would take a square root. What did I say? I would take a square root. I think I said I took a square root. Oh, very good. So whenever I take a square root, I always have to count for the plus or minus possibility. I think I said that a time or two.
Yeah.
Now the square root of 1/3. What's the square root of 1? What's the square root of 3?
We don't have to rationalize. Right?
We don't want to rationalize this because this is not our final answer.
Yeah.
Like if I was giving you the final answer, you would need to rationalize it. But right now, we're still trying to get x by itself. And think about it. Tangent is the opposite over adjacent. And I like both of those sides. I like a side of 1 and a side of radical 3. So I do not want to rationalize that. So let's think about it. Tangent of some angle gives plus or minus 1 over radical 3. So tangent could be positive or negative. So what quadrants could tangent be positive or negative? Any quadrant. Tangent is the opposite over the adjacent. So the opposite side is 1. The adjacent side is radical 3. Hopefully you can see that. That's okay. So if opposite's 1, adjacent's radical 3. That's a 30-degree reference angle. So then the question is, how much did I rotate to get 30 degrees in the first quadrant? Power 6. How much did I rotate to get 30 degrees in the second quadrant? How much did I rotate to get 30 degrees in the third quadrant? How much did I rotate to get 30 degrees in the fourth quadrant? Oh, you guys can't see all that. Questions? You guys want to try 4 on your own? Do you want me to do 4? I'll give you a chance to try from the get-go. Makes my head hurt looking at it, but I'm old.
I can't take the square root of it.
Now you can't take a square root because there's another sign of x.
Yeah, that's where I'm stuck.
So you're going to have to factor. No, you can't factor out a sign. If you move the 1 over, but then you're in no man's land. When we factor, we like for it to say it equals 0. So you can't move that negative 1 over. That's just going to cause a bit of headache. So the way I would factor this is I would do what's called a U substitution.
2u squared minus
I'm going to let U be equal to the thing that I think is ugly in this problem,
sine x.
which is sine of x. So now everywhere it used to say sine of x, I'm going to just say U. So this is 2 sine of x squared minus sine of x minus 1 . Can you factor from there? It's the same thing as example 4 above it. Is it not? Our example 4?
Oh, yeah.
That's amazing. I used to could factor that in my head, and I can't anymore. I might could if I really strained hard.
You're just out of practice.
I always do the A times C method now. But like when I was in school, they never showed us A times C. On that, we always had to do trial and error. We just had to try something. If it didn't work, try again. And I could figure out in my head. I would do all the different combinations. That's a terrible way to think about it. I don't know if my teachers didn't know the A times C method, or if they just didn't believe in it.
And then when you get the answer, you plug it back in.
So when you factored, you should get. What did we get when we factored it?
2u squared minus 2.
No.
Oh, you want the whole thing?
Yeah, what's the factored? What's the answer?
2u plus 1, u minus 1.
Is everybody okay with that, or do I need to go through how to get that? We did it earlier. So now, I could say 2u plus 1 equals 0, u minus 1 equals 0. So this would be u equals negative 1/2, and u equals 1. You okay with that? But the question never asked me what's u. The question asked me what's sine, or what's x, actually. So I have to take this and plug it back in for u. So this says sine of x could be negative 1/2, or sine of x could be 1. Both of these situations are things we can do without a calculator. So the first one gives a ratio for sine that is negative. Sine is negative in the third and fourth quadrants. All students take calculus. Sine is a ratio of the opposite over the hypotenuse, which means the missing side's radical 3, which means my reference angle is 30. So then the question is, how much did I rotate to get 30 degrees in the third quadrant? 7 pi over 6. How much did I rotate to get 30 degrees in the fourth quadrant?
11 pi over 6.
And so that's 2 of my answers.
But isn't it only 2? Because it's squared. Does that mean there's all the others?
No.
Oh, there's no x.
I solved this one. Now I have to solve this one. Where is sine of x 1? Well, it's not a ratio. So that automatically makes me think when it's sine or cosine, I must have rotated to an axis. Sine is the y value. So I'm looking for where the y value is 1 when I rotate, and that's up here. That's where I get a y value of 1. So how much did I rotate to get there? Pi over 2. So I have 3 solutions. There they are. Pi over 2, 7 pi over 6, 11 pi over 6. Working the problem is this, I think I got correct. Cosine of x equals 1/3. Cosine of x equals -2. Did we get to that point? So now from here, you see that ratio for cosine, adjacent and hypotenuse. Do you guys know a triangle that has an adjacent side of 1, a hypotenuse of 3? No, that's not going to be an angle that we recognize. So when I have to use a calculator, I have to keep going to get x by itself. So why is x not by itself? Because we're taking cosine of x. So how can I undo a cosine? I could take the inverse cosine of both sides. So the inverse cosine of cosine cancels, and we're left with x equals. And then we've got the inverse cosine of 1/3. So make sure your calculator is in radians, and find what the inverse cosine of 1/3 is. $1.231. Do I have a second? Is this the only solution for this equation?
Oh, do you have to add that from or subtract it from one of the x-axes where how we did the other one?
So this problem didn't originally have an inverse cosine in it. I put the inverse cosine there, which means I need to give all x values between 0 and 2 pi that make it true. The problem is, remember, inverse cosine, I have restricted the domain. And inverse cosine is only valid in the first and second quadrants. But the ratio of cosine can be positive in the first and fourth quadrants. So this spit out the answer for the first quadrant. I need to find the answer for the fourth quadrant. No. So this was in the first quadrant, right? So again, I know it's kind of hard to make sense of it because it's not just like an angle we're used to seeing because it's in radians. But I know it's in the first quadrant because it is a positive ratio. So I know this is quadrant 1, which means I rotated in total 1.231 radians to get there. So what would the reference angle need to be in the fourth quadrant? It would need to also be 1.231. Right? So how could I find the reference angle in the fourth quadrant? Like the easy answer would be, say, negative 1.231. But that's not allowed because it has to be between 0 and 2 pi. Our answer does. So then I'm thinking, well, if I rotate it all the way around, that's 2 pi. And then if I backed up 1.231, that would get me to this terminal side. So I would do 2 pi minus 1.231 to find the other angle in that quadrant, which is 6.28. That's going to be 5.05 something. 5.052. What are our thoughts? That's tough.
Okay, so I thought that it was only like valid in the first and second quadrant.
Inverse cosine is only defined in the first and second quadrants. So once you put inverse cosine of 1/3 in your calculator, you know it's going to give you an answer in the first or second quadrants only. But the problem didn't say, like, it didn't start off saying, give me the inverse cosine of 1/3. That's not the original problem. The original problem is cosine of what angle gives a ratio of 1/3. And so from the get-go, I know this has two answers in the first and fourth quadrants. And so the inverse cosine with my calculator will give me the first one on its own. Then I'm going to have to do math to find the other one. So
Because it was positive, you knew that it was only in the first and fourth quadrant.
that's correct. These are really asking almost the same thing. This says cosine of what angle is 1/2. Well, because it's positive, it could be in the first or fourth. And I know cosine is adjacent over hypotenuse, so the angle's 60. And then I can figure it out from there, what the two are. So this question has two answers. Pi over 3, 5 pi over 3. For 60 degrees in those two. If this was my question, this only has one solution. Because inverse cosine is only defined for the first or second first or second quadrants. And because the ratio is positive, I know I'm in the first quadrant, and I can figure it out from there. It's all about how the question is asked. It didn't originally have an inverse cosine. I chose to do that. To help me find an answer.
So if the 1/2 was negative, it'd be in the second one.
That's correct.
Okay.
And if this was negative here, there would only be one answer in the second quadrant. If this was negative here, there'd be two answers in the second and third quadrants. It's all about how it started. Just like, it really falls in the same category as if you're given this problem, what's the square root of 9? If you're given this problem, the answer is 3. It's understood to be only the positive root. If there's just a square root on its own, it's the principal square root, only the positive. But if I was here, and I have to solve, and I choose to take a square root, I do plus or minus. It's the same idea. I invoke the inverse arc cosine. I invoke that. It wasn't there originally. It's hard to say invoked and inverse in the same sentence. It's too many ends for my small brain. Now here, okay, we found two solutions for this ratio. Now this one. Cosine is -2.
It doesn't count.
Can't happen. If you think about cosine oscillates between -1 and 1. Well, how could we ever get to -2? Well, we couldn't without some kind of transformation. We don't have a transformation, so it's D and E. If you wanted to, in your calculator, if you put inverse cosine of -2, you should get, math error, syntax error, I don't know what it'll spit out at you. But it's not going to work. So from this one, we get nothing. So the only two solutions are those two.
All these back problems.
cotangent of x squared of x equals 2 cotangent of x. You're crazy. Anyways, if I've got cotangent of x, cosine squared of x equals 2 cotangent of x. Thoughts?
Do we have to like change the cotangent to sine or cosine or no? Or no, it's
You
cosine.
could, but I think that would be. I don't think that's the play. You might could do that. That might could work. That's not what I. That's not my initial instinct.
Cause could you use two different variables, or that's just put you in a bad spot too?
Oh,
Two variables, two trig functions. Which one do you mean?
Like variables, like change the say cotangents x, say cosines y. But that would still put you in a bad spot because you still got two different things that can't combine. Never mind.
can you put the cotangents together?
Okay, so because there's two terms in total, if I get those two terms on the same side, both of them would have a cotangent. They would have a GCF. So I think that would be the route I would go. I would get them on the same side. Cotangent of x, cosine squared of x minus 2 cotangent x equals 0. Two terms, they both have a cotangent. So GCF, cotangent of x. That leaves me with cosine squared of x minus 2. Hmm?
Never mind. I don't know how to go from there.
We okay with that? So it's just some math. I'm just trying some math. Now then, I have two things multiplied to be 0. So one of them has to be 0. So let's set them both equal to 0. So cotangent of x could be 0. Or cosine squared of x minus 2 could be 0. This screams at me I'm rotating to an axis. Right? So in my head, this is what I had to do. Tangent is y over x. So cotangent is x over y. So because I'm looking x over y, I need x to be 0. And I need y to just be some number. Are we following? So where can I rotate to get an x value of 0? That's it. So this equation spits out two solutions, pi over 2 and 3 pi over 2. I just realized like what a technical math teacher I am. I just told you this equation, it spit two things out at you. What are we talking about? This. Anyways, sorry. I'm just the sand mountain in me. I can't get it out. Like, no matter how detailed I know this math, I can do it. I still got. It's gonna spit that out at you. I tell you what. What am I talking about? Okay, here if I solve cosine squared of x equals 2. Cosine's not by itself yet because it's being squared. So I have to take a square root. So I chose to take a square root. Plus or minus. What's the square root of 2? Radical 2. There's no denominator. I could put it over 1. Or, I really don't have to. Like, if I put it over 1, which side is bigger? Is radical 2 or is 1 bigger? Radical 2 is bigger than 1. So then the hypotenuse would be smaller on a... Can't happen. Okay? So this one gives nonsense. Does not exist. Because again, if you think about it, cosine can only oscillate between -1 and 1. Radical 2 is bigger than 1. It's like 1.4 or something. So that one would give that one gives no solution. So that would be my 2 answers. Okay, cosine of pi over 3x equals 0. This looks awful to me. Right? So what did we do before when I had something that looked awful? I just did a U substitution. So if I was given this problem, I would do a U substitution from the beginning. I would say cosine of U has to be 0. Now I feel much calmer, much more in control of the situation. So how much did I rotate to get 0? Well, that's on an axis. Cosine is the x value. So where's x 0?
1/2 pi 3 over 5.
That's it. Huh?
The only answer.
Those are the only two on 0 to 2 pi. Now, these are not the final answers though. This is what u is equal to. But I did a u substitution. So if u equals pi over 2, then that means, oh gosh, I'm running out of place. It's going to look awful. Yep. Pi over 3 times x equals pi over 2. And pi over 3x equals 3 pi over 2. I'm running out of room. I'm sorry. I know this looks awful. We okay? What I've done? I put the x in the numerator instead of writing it beside it. You know you can do that. If the x is multiplied beside it, I can just move it to the numerator. Why would I do that? Because now I have a...
Fraction equal to a fraction.
I love that. Boy, I do that all the time, don't I?
Yeah.
That's just one of my... if you do another class, they may not do that as much, but that's my go-to. Fraction equal to a fraction, I cross multiply, set them equal. So 2 pi x equals 3 pi. Divide by 2 pi. So x equals 3 over 2. Do the same thing here. I would get 2 pi x equals 9 pi. So it'd be 9 over 2. And this is 4.5. Right? 9 over 2, 4.5. And so there's not going to be another one past it if it wants all answer between 0 and 5. So that's the last answer.